can't physically go 1, 2, 3. It's not.
Yeah.
Maybe not zooming. Oh, there we go.
There's types. There's, you see how it's different types. Like different types.
So,
My question, because I got that.
just so everybody understands, what these guys did right here, they were asking me about one of the assessments, the quizzes.
It's not.
That's totally fine. We were in the middle of a break at that point. I got no problem doing that. So on the first quiz you took, one of the true-false questions was, I will answer questions on assessments in class. And the answer is false. I won't. But during a break, that's not really class. If that's the only time you've got to ask me a quick question, I'm totally fine with that.
Okay, good.
Now I won't answer it. Now I'll ignore you. So, but while we're in between breaks, before class, right after class, I got no problem as long as we got
Hell is
time.
no will answer.
As long as we got time.
That's what I put on the
What did I do? Here we go.
Time, assessment's open.
Now, back to business. Now, I want to get back, I want to tie in what we just learned about the lollipops to what Tom said about the half above, half below, which I love, by the way, to all these words you guys came up with. Now, as it turns out, there are at least 10, if not more, measures of central tendency. There are lots of them. There are tons. There's something called the harmonic mean. There's something called the geometric mean. There's something called the arithmetic mean, which you guys generally just call the mean, or most usually the average. When you hear, you notice I put average in quotes? That's because the word average can mean different mathematical things. Sometimes it's just used to represent the mean. Now the mean, the arithmetic mean in particular, we'll just call it the mean though, is what you guys just calculated. When you guys were trying to add up all the data and divide by 10, that is the arithmetic mean. The arithmetic mean is found by summing all the data points and dividing by the number of data points. I should say summing all data values, not points. Summing all the data values and dividing by the number of data points. It's what you've learned how to do since you're probably in 3rd grade. I remember when I was in 2nd grade taking spelling tests once a week with Mrs. McFeet, I think her name was, if I remember correctly. Spelling test, 20 questions, 5 points for each question's done right or wrong. And I remember she thought me and my friend Matt were cheating on one. She took them both away from us. And it took me about 35 seconds to realize with a 0 on a test, my average was going to go down. Because I could add up. Even though I was getting hundreds on the rest, 100 plus 100 plus 100 plus 100 plus 0, divided by n minus 1 or n plus 1, was going to be a fairly small number compared to if they were all hundreds. So very early on, you understand this. Very early on, you understand this formula. But as who mentioned, now I finally understand it. Was it you, Candace? Somebody said, now I finally understand why. Elizabeth. Correct. So yeah, because once you see it laid out like that, you understand why you do this. It ties in to that, I wouldn't call it any of these. It's not middle, it's not frequent, it's not common, it's not probable, it's not typical necessarily. It's even. If you think, it's an even distribution of data. That's what it does. It's the number that represents all the data evenly distributed, uniformly distributed across all the data possible points. So it's like an even or equitable, I guess, assignment of resources. I mean, really, that's kind of what it is. It's taking all the data, and it doesn't matter how much you had originally. We're going to throw it all into a big pot, shake the pot out, and break it up into even piles, and everybody gets an even pile. That's what the average actually tells you. You don't actually have to do that with the resources, but that's what the average is telling you. If you all had the same number of these things, you'd have this many. Now, I want to introduce a little bit of symbolism here. Statistics is full of ideas that are written out in sentences like this, and it becomes easier in a lot of ways to use symbols to talk about them versus the sentences. So, summing all data values. That is something we do an awful lot in this class. We add a lot. We also subtract a little bit too, but we spend a lot of time adding. Rather than writing summing up all blah 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 blah, there's a symbol that is used instead of using that called capital sigma. Looks like that. It's like a big, it's like a big E, but it's actually the Greek letter S, which is the first letter in the word sum, which is convenient. You'd be amazed at how many of these words have leached into your math classes without you realizing. You know why pi is pi? And they use the Greek letter pi for pi? Do you know what pi is on a circle?
Yes.
So if you take the distance around and divide it by the distance across, that's what pi is. Well, the distance around, remember what the distance around is called? Circumference. But they didn't used to call it that. What's the distance around any polygon? Perimeter. And originally it was called the perimeter of a circle as well, and they used pi for perimeter. That's why pi is pi. It's always got some kind of historic reason as to why we use the things we use. So sum, sound, sigma. So when you see this, it means add up a bunch of stuff. Add up a bunch of stuff. We're adding up a bunch of data values. Data values generally in this class are indicated by little x's. So for example, Tom, how many light bulbs did you have originally in your little, let's say,
A lot.
A lot.
6.
6. Tom's x value would have been 6. Blake's x value was 0. Sorry. Candace, your x value was 3. So all of those x values are just called x's, and you add them up. So that's what that means, add up. And divide by how many data points there were. How many folks were up here? 10. It could have been 20. It could have been 100. It could have been anybody. We just call it little n. Little n is a sample size. Little n is your sample size. That way we could say, what's n? For large values of n. For small values of n. What n do we need to get a power of 80%? That's a 244 question, but it's one of those things. We kind of keep that n in there all the time. Please, Katie.
Okay, sum, and then what's the x stand for?
X is for just for data.
X.
So this means add up.
All
This
the
means
data.
data. And whenever you see an x, it's just data in this class.
So add up all the data.
Add up all the data and divide by how many points there were originally. And that becomes the average. Go ahead, Candace.
So that might be taking the place of before in a math class we might have seen brackets and parentheses.
This plus this plus this plus this plus. Yeah, absolutely. It's shorthand is all it is. It's shorthand is all it is. I used to have a whole unit on just the summation notation, but students don't like it very much. And I realize it's overkill. You don't need it. As long as you understand what that big sigma means, which it means add. And we even get tired of typing the word average or mean. So we simply put x bar for the sample mean. I shouldn't say we. Somebody at some point did x bar and we're saddled with it. So when you see x bar, that means a sample average. There's also a population average. There's a population average or population mean. We'll talk more about him on Thursday. His name is mu. M-U, like the sound the kitten makes. Mew. And it's called mu because it's a mean. M sound in Greek. Mu. But we don't talk about him so much in this class. Do you know why? Why do you think we talk about a sample average more than a population average? We often are interested in a population average. But we use sample averages a lot more. Anybody have any idea why? We mentioned this on the first couple days of class, but you may have forgotten.
Easier.
More possible, correct? Isn't it more possible to get a sample than the entire population?
Right.
We have one of those discussions. How hard is it for the US government to do a census? You have to do a census to get the population average mu. It's really hard to do. Way easier to get a sample average, x bar. So this is all based on sample data. Sample data. Cool? Awesome. What I want to do right now is, I want to dive into this. I want to dive into this with the data I collected from you guys at the end of the day Thursday. I'll pull the screen now. Remember the last question I asked you on Thursday?
Keys.
How many keys did you have with you that day? Yes. Yes, how many keys did we have that day? Oh, I'm sorry, guys. Beat you over your head.